Hello students, this is grade 10 physics class, chapter 12, electricity. In last video class we have seen what is electric power and SI unit of electric power and then some formulas for calculating the electric power. Am I right? Yes. In this session we are going to start our next very important topic. What is that? Very important topic. Yes. So in order to start our next topic, we must recall what are the things we have seen in previous video class. Is it clear? Yes. So last class we have seen the electric power. Am I right? What is electric power? Yes. Actually, so what is electric power, sir? What is electric power? Yes. The rate at which the electrical work is done, that is called electric power. The rate at which electrical work is done, that is called electric power. Okay, which means per second how much amount of electrical work is done, that is called, what is that? Electric power. So electric power, that is equal to work done divided by time. Work done divided by time. Yes. So we can say the electric power in two ways. In two ways. First in terms of work done and second one in terms of energy. Energy, because work done, that is equal to energy. So whenever work is done, equal amount of energy is consumed. So work done, that is equal to energy. So we can say the electric power in two ways. First one in terms of work done and second one in terms of energy, electrical energy. Is it clear? So we can say per second how much amount of electrical energy is transferred, or otherwise we can say per second how much amount of electrical energy is consumed by an electrical appliances. That is called electric power. That is called electric power. Is it clear, students? Very easy one. Okay, yes, so work done, that is equal to, electric power, that is equal to work done divided by time. Isn't it? Yes. So after that we have seen what is that? Yes, SI unit of, the SI unit of electric power. Yes. What is the SI unit of electric power? What is the SI unit of electric power? Yes, the spelling will be different. Watt, W-A-T-T. The watt is the SI unit of electric power. Is that clear? Yes. So 1 watt, then after that we have seen 1 watt. What is 1 watt? So 1 watt, that is equal to 1 joule divided by 1 second. 1 joule divided by 1 second. Yes. So what is it meaning, sir? What is it meaning? So when an electrical appliance consumes 1 joule of electrical energy in 1 second, then the power of the appliance is said to be 1 watt. 1 watt, that's all. So 1 watt, that is equal to 1 joule divided by 1 second. Is it clear? It's very easy. Yes. Then actually, so watt is a very smallest unit. Watt is a very smallest unit, because look at here, 1000 watt, that is equal to 1 kilowatt. 1 kilowatt. This watt is a very smallest unit, so we need some alternative unit for calculating the electrical energy, that is kilowatt, because kilowatt is a bigger unit. Compare than watt, kilowatt is a bigger unit. Okay, yes. So 1000 watt, that is equal to 1 kilowatt. 1000 watt, which is equal to 1 kilowatt. Is it clear, students? Yes. So I define 1 watt. 1 watt, that is equal to 1 joule divided by 1 second. So when an electrical appliance consumes 1 joule of electrical energy in 1 second, then the power of a electrical appliance is said to be 1 watt. Okay. So at home we use different kinds of electrical appliances. They all electrical appliances having power rating. What is that? Power rate. For example, the tube light power rate is 40 watt. Okay, maybe different. Maybe that is different from one bulb to another bulb. I am telling approximately here, not exactly. Okay, the tube light bulb rating is 40 watt, which means that tube light consumes the 40 joule electrical energy in 1 second. In 1 second, that is a meaning. Okay, yes. Then the fan electrical power rating is 150 watt. What is that? 150 watt. What is it meaning, sir? What is it meaning? So when we switch on, the fan starts rotating. Fan will start rotate. Am I right? Why? Because the fan consumes the electrical energy. So already we know that fan electric power rating is 150 watt. So here that fan consumes the 150, note this point, 150 joule energy. What energy? Electrical energy in 1 second. So that that fan power rating is 150 watt. That's all. Is it clear? So 1 watt, which is equal to 1 joule divided by 1 second. So whenever the electrical appliances consumes 1 joule electrical energy in 1 second, then the power of electric appliance is said to be 1 watt. 1 watt. Actually 1 watt, okay, we generally watt. 1 watt is a very smallest unit. So 1000 watt, that is equal to 1 kilowatt. Kilowatt is a bigger unit compared than watt. So most of the numericals we are going to take only the kilowatt. Is that clear, students? Yes. Then after that we have seen some formulas for calculating the electric power. Am I right? Some formulas for calculating the electric power. Am I right or wrong? Yes. So what are the formulas, sir? So what are the formula? Yes, first formula, that is power which is equal to voltage into current. Okay, I'll write that. Look at here. The power which is equal to, first formula, the power which is equal to, what is that? Yes, voltage into current. P, that is equal to V into I. This is first formula. And second formula, what is that, sir? P, which is equal to I squared R. P, that is equal to I square R. That is also one of the formula for calculating the power rating. Okay. Yes. And third one, P, that is equal to V squared by R. P, which is equal to power, which is equal to V squared divided by R. Is it clear? Yes. So there are three formulas for calculating the electric power. So first one, that is power formulas in terms of voltage and current. Second formula, this is second formula for calculating power in terms of current and resistance. And third formula, that is in terms of voltage and resistance. If you know any two values, we can calculate the power rating. Is it clear? We can calculate the power rating of an electrical appliances. Isn't it? That's all very easy one. Okay? Yes. So till now we have seen up to this. Am I right, students? Yes. Till now we have seen up to this. I'll drop this. So now we are going to start the very important topic. That is basic for the kilowatt hour. Okay, yes. So now I am going to start very important topic. Is it clear? Yes. Look at here. At home we use different kinds of electrical appliances. Different kinds of electrical appliances such as television, refrigerator, air conditioner, microwave oven, an air conditioner, then the fan, tube light, and so many things we use every day at home. Am I right? These all electrical appliances consumes the electrical energy and they are functioning. Is it clear? Yes. So already we know these all electrical appliances consumes the electrical energy. Do you know how much amount of electrical energy which is consumed by the electrical appliances? Do you know that? I don't know. I don't know how much amount of electrical energy which is consumed by an electrical appliance. I don't know. Then how can we calculate, sir? Then how can we calculate the amount of electrical energy which is consumed by the electrical appliances, sir? Electrical appliances. Do you think the all electrical appliances will consume same amount of power? Same amount of power? No, that is not possible. Different electrical appliances are having different power rating. What is that? Power rating. So the different electrical appliances consume different amount of electrical energy. For example, the bulb may consume the less amount of power. Then the fan may consume more amount of power. The refrigerator may consume more and more amount of power. The air conditioner and the washing machine may consume more and more amount of power. So the different electrical appliances consume different amount of electrical energy. Is it clear? Yes. Okay, sir. So already we know the all electrical appliances consumes the electrical energy and they starts functioning. Am I right? How much amount of electrical energy which is consumed by the electrical appliances? That is very big question. How can we calculate that, sir? How can we calculate that? For example, look at here, that fan is rotating for 1 hour. That fan is rotating for 1 hour. That fan power rating is 150 watt. Okay, that fan power rating is 150 watt and that fan is rotating for 1 hour. How much amount of electrical energy which is consumed by the fan during that particular time? During that particular time, you tell me. How much? We don't know, sir. We don't know. We need to calculate. We need to calculate how much amount of electrical energy which is consumed by an electrical appliances. Sir, how can we calculate, sir? How can we calculate? Yes. To calculate that we need some formula. We need, of course, we need some formula to calculate that. Okay. That question I am going to start with this class session. Okay. Yes. So we will start with class the new important topic, that is formula for calculating electrical energy or electric energy, no problem. So formula for calculating the electrical energy. Okay, today we will start with a new important topic, that is formula for calculating electrical energy. Okay, so already we know, so all electrical appliances functioning because of electrical energy. If electrical appliances are running, which means functioning for a particular time, how much amount of energy which is consumed by the electrical appliances? That is very big question. So in this session we are going to discuss about that. Okay, students? Yes. So what is that question? The formula for calculating the electrical energy, isn't it? Yes. So already we know the electric power or power, both are same here. So electric power which is equal to, what is that formula? Yes, work done divided by time. Electric power that is equal to work done divided by time. Is it clear? Yes, which means, what is that, sir? The rate at which electrical work is done. The rate at which electrical work is done, that is called electric power. Already we know very well. Which means per second, how much amount of electrical energy transferred or consumed by an electrical appliances, that is called electric power. That is called electric power. Is that clear, students? Yes. So we can write electric power that is equal to work done divided by time. Work done divided by time, isn't it? Yes. See, already we know, whenever work is done, equal amount of energy is consumed. Whenever work is done, equal amount of energy is consumed. Am I right or wrong? Yes. For example, here, look at here. Here, that bulb is glowing. That electrical bulb is glowing. Suppose if that electrical bulb done the work as in the amount of 10 joule. Look at here. If the electrical bulb done the amount of work is 10 joule, how much amount of energy is consumed? Yes, same 10 joule amount of electrical energy is consumed. If the electric bulb is done 10 joule amount of work done, the same amount of 10 joule energy is consumed. Same amount of 10 joule energy is consumed. So whenever work is done, equal amount of energy is consumed, because work is possible because of only energy. If energy is not there, work is not possible, which means work done is not possible. Is it clear, students? Yes, look at here. So I am making these videos in front of you because of my body energy. If I don't have any energy, I cannot make this video. Okay, here making video, that is work done. Here I am making this video because of my body energy. Because of my body energy. If I don't have any energy, I cannot make this video, which means I cannot do any work. I cannot do any work. So whenever work is done, equal amount of energy is consumed. Suppose if the bulb is done 10 joule of work, the equal amount of 10 joule of energy is consumed. Equal amount of 10 joule energy is consumed. Both work done and energy SI unit is same, that is Joule. Okay, keep this point in your mind. Both work done and the energy SI unit same, that is Joule. Okay, so whenever work is done, equal amount of energy is consumed. Is it clear? Yes. So look at here, we can write work done. Here what work done? Electrical work, or otherwise we can say electric work. Okay, yes. So work done, that is equal to energy consumed. Work done, that is equal to energy consumed. Is it clear? Yes. So we can write energy instead of this work done. Am I right? Because both are equal. Work done, that is equal to energy consumed. So we can write energy instead of work done. Am I right or wrong? Yes, obviously we can write, no problem at all. Okay. Yes, I'll write here. So we can write electric power, which is equal to, you write here, energy. Okay, instead of this work done, so we can write energy, because work done, that is equal to energy. So energy divided by time. Energy consumed or energy, both are same, no problem. Okay, all the times no need to mention this full word like energy consumed like that. Just we can write energy. And for that electric power also, just we can write power, no problem at all. Okay, yes. So electric power, which is equal to energy divided by time. What is that? Energy divided by time. Is it clear? Yes. See, we need only energy. So look at here, the question is formula for calculating electrical energy. Okay, so we need to make a formula for this electrical energy only. Isn't it? Yes. So when this term, which means time, come this side, what will happen? This division changes into multiplication. So we can get, note this point. So energy which is equal to, what is that? Power into time. This is very, very important formula. Very important formula. Power which is equal to, energy that is equal to power into time. So this is a new formula. So we have calculated the energy formula. So energy which is equal to power into time. Is that clear, students? Very easy, students. So the product of power into time, that is equal to energy. Isn't it? Yes. So energy is denoted by the letter capital E. And power is denoted by the letter capital P, not small p, capital P. And time is denoted by the letter small t. So we can write E, which is equal to P into T. So this is a formula to find out the energy consumed by an electrical appliances. That's all, friends. So this the product of power and time, that is equal to energy. Is that clear? Very easy one. Okay, yes, look at here. For example, that electric bulb, the tube light power rating is, what is that? The tube light power rating is 40 watt. This is for an example. The tube light power rating is 40 watt. Okay, students? Yes. Then that tube light is glowing for 60 seconds. 60 seconds. Now what is the energy, sir? And how much amount of energy which is consumed by the electrical appliances of power rating 40 watt, and the time for it is used 60 seconds, sir. So energy, already we know energy, that is equal to power into time. So power value how much? Yes, 40 watt into time 60 seconds. So what will be the value? Yes, 1400 joule, because energy SI unit is joule. So here the value will be, what is that? Yes, 1400 joules. That's all. This is how we need to calculate the energy. That's also very easy one. So look at here. So 2400 joule amount of energy which is consumed by an electrical appliance is having the power rating of 40 joule and it is used for 60 seconds. That's all. So that's all, very easy one. So suppose if the electrical appliance is having the power rate of 60 watt and it is used for 60 seconds, then the electrical appliances will consume the power rating, which means electrical energy will be 2400 joule. That's all, students. Very easy one. Very easy. Is there any doubt? No doubt. So this is how we need to calculate the energy, the electrical energy which is consumed by any electrical appliances. Is that clear? Yes. So this formula is very important. E that is equal to P into T. E that is equal to P into T. Okay? Yes, very good. Very easy one. I'll drop this. Look at here. So energy. So energy which is equal to power into time. What is that? Energy, electrical energy that is equal to power into time. Am I right? Yes. So which means E which is equal to P into T. P into T. Is it clear, students? Yes, very easy. So now look at here. Now look at here. The refrigerator. What is that? Refrigerator. The refrigerator power rating is 100 watts. The refrigerator power rating is 100 watt. Yes. That refrigerator is functioning for 1 hour. 1 hour. Then how much amount of electrical energy which is consumed by the refrigerator having the power rating of 100 watt and it is used for 1 hour? How much, sir? You tell me. Yes. So convert this hour into seconds. That will be 3600 seconds. So then energy which is equal to, already we know, power into time. So power value, yes, 100 watt into time 3600 seconds. Then the watt will be the value. Yes. After 36, how many zeros will be there? Yes, 4 zeros will be there. Joule. Here, watt into second, that is equal to joule. So how much? 3,60,000. 3,60,000 joule energy is consumed. That's all. So look at here. Here 3,60,000 joules amount of energy which is consumed by an electric appliances of refrigerator having the power rating of 100 watt and it is used for 1 hour, which means 3600 seconds. That's all. If the refrigerator having the power rate of 100 watt, it is used for 1 hour, then it will consume the electrical energy rate will be, what is that? 3,60,000 joule. That's all, students. Very easy one. Very, very easy one. Okay, so this is how we need to calculate the electrical energy which is consumed by the electrical appliances. At home we use different kinds of electrical appliances. The different kinds of all electrical appliances functioning, which means running in different times. So for example, the TV and a fan, fan and so many electrical appliances are running throughout the day. Okay, throughout the days, so maximum amount of time. Am I right? Yes. So this is how we need to make electrical energy which is consumed by an electrical appliances. Is that clear? Is there any doubts? So very easy one. Energy that is equal to power into time. You keep this formula in your mind. Is that clear, students? Very easy. Okay, yes. So next one. Okay, sir. Formula for calculating electrical energy. Okay, sir. To calculate the electrical energy, we have a formula. Note this point. To calculate the electrical energy, we have a formula, that is energy which is equal to power into time. Energy which is equal to power into time, isn't it? Yes. Next one, commercial unit of electrical energy. What is that? Commercial unit of electrical energy. Commercial unit of electrical energy or electric energy. Same. You don't get confusion. Okay. The commercial unit of electrical energy. So what is a commercial unit of electrical energy, sir? What is commercial unit of electrical energy? So already we have a formula to calculate the electrical energy, that is energy that is equal to power into time. Then what is commercial unit of electrical energy, sir? And why do we need commercial unit of electrical energy? That is very big question. That is very big question, because already we have a formula to calculate the electrical energy, how much amount of electrical energy which is consumed by an object when it is used for particular time, isn't it? Yes, that is the energy that is equal to power into time. What is commercial unit of electrical energy, and why do we need commercial unit of electrical energy? That is very big question. That is very, very, very important question. Is it clear? Yes, look at here. Commercial means nothing but money, economically. Okay, economically, to calculate the electrical energy consumed by an object, which means electrical appliances, what is the unit? What is the unit? Look at here. Economically, how much amount of electrical energy which is consumed by an electrical appliance is, to calculate that we need commercial unit. We need commercial unit. That is the commercial unit of electrical energy. Sir, how can we calculate the commercial unit of electrical energy, sir? How can we calculate the commercial unit of electrical energy? That is very big question. How can we calculate, sir? How can we calculate? Look at here. Every 2 months once we pay electricity bill to TNEB, which means Tamil Nadu Electricity Board. Am I right? Every 2 months we pay. You also paying, I am also paying the electricity bill, isn't it? Yes. Why we are paying that, sir? Why we have been paying the electricity bill to the Tamil Nadu Electricity Board, which means the TNEB? Why? Yes, you can say, sir, we use electrical appliances at home, sir. That is the reason why we pay electricity bill to TNEB, sir. Yes, that is the reason why we are paying. Of course, that is right. Yes. What basis? Look at here. On what basis they are making the electricity bill to us? What basis? Have you ever thought like that? Okay, simply the electricity board worker, okay, the officer, which means the EB officer, they are alerting, which means they are giving the electricity bill to us. So we are paying that. We are paying that. Am I right? Yes. Have you ever thought why we are paying like that, and what basis we are paying that amount of electric bill to? No, we never thought like that. Am I right? Yes. But if you listen in this class, definitely you will get some idea. So why we are paying electricity bill, and how much we are paying electricity bill, and how much amount of energy which is consumed by the electrical appliances functioning at home. Really, you can get some clear idea. Okay, so from the topic of commercial unit of electrical energy. Is it clear, students? It's very easy. Let's get started. Okay, yes. Look at here. So already we know, to calculate the electrical energy consumed by an object, which means electrical appliances here, that is, we have a formula, that is, what is that? That is power into time. What is that? Power into time, which means E that is equal to P into T. Okay, then what is commercial unit, sir? Then why do we need commercial unit, sir? That is next question. Okay, that is next question. Is that clear? Yes. First we will start with, why do we need commercial unit? Why do we need commercial unit of electrical energy? Is it clear? Yes. Look at here. So already we know energy which is equal to power into time. Power into time. Already we know very well, isn't it? Yes. Look at here. Here, what is the SI unit of power? That is watt. The SI unit of power is watt. And what is the SI unit of time? The SI unit of time is seconds. Second. The SI unit of time is second. Is that clear? Yes. Listen here. Put 1 and 1 in front of both quantities. 1 watt into 1 second. What is that? 1 watt into 1 second. Is that clear, students? Yes. So here, this is energy. That is energy, isn't it? So energy SI unit is joule. So we can write 1 joule. Energy SI unit is 1 joule. So listen here. So 1 joule, that is equal to 1 watt into 1 second. What is that? 1 joule into 1 watt into 1 second. Actually, what is it meaning, sir? What is it meaning? 1 joule, that is equal to 1 watt and 1 second. So what is it meaning? What is that meaning, sir? Look at here. Look at here. 1 joule amount of, notice point, 1 joule amount of electrical energy is consumed when the electrical appliance is having the power rating of 1 watt and it is used for 1 second. That is called 1 joule. That is called 1 joule of energy. Okay, look at here. 1 joule amount of so when 1 joule amount of electrical energy is consumed, the electrical appliance is having the power rate of 1 watt and it is used for 1 second, then the energy consumed by an object, which means electrical appliance, is said to be 1 joule. That's all. 1 joule. Is it clear? Yes. I think you are not understanding. Am I right? Yes, look at here. I'll explain clearly. Okay, yes. Consider the electric circuit. Consider the electric circuit. Yes. Here I have taken a bulb. I have taken an electric bulb, isn't it? Yes. Look at here. This electric bulb power rating. What is that? Power rating is 1 watt. Consider electric circuit. This I have taken an electric bulb. The 2 terminals of the electric bulbs are connected across the 2 terminals of the battery. Okay, so we apply voltage, 220 voltage, which means potential difference. Okay, yes. So due to the potential difference, the current gets flowing in the circuit. So this electrical bulb consumes, note this point, consumes the electrical energy and it will produce light energy. Light energy, isn't it? Yes. Look at here. Here the electric bulb power rating is 1 watt. Just 1 watt. Just only 1 watt. So this electrical bulb power rating is 1 watt. Is it clear? Yes. And this, note this point, and this bulb glowing for 1 second. And this bulb glowing for 1 second. Is it clear? Yes. Look at here. If the bulb power rating of 1 watt is glowing for 1 second, then the energy consumed by the electrical bulb will be 1 joule. 1 joule. That's all. That is the meaning for this. That is the meaning for this one. This one. When the electrical appliance is having the power rating of 1 watt, it is used for 1 second, then the energy consumed by the electrical appliances will be 1 joule. Will be 1 joule. That is the meaning. Is it clear? That is the meaning. So here 1 joule, that is equal to 1 watt into 1 second. 1 second. Look at here. Here the watt, here the power, which means the power rating. Here the power rating and the time is too small. Too small. Am I right? Yes. Here the power rating is only 1 watt. Only 1 watt. And time is just only 1 second. Just only 1 second. But in a realistic, note this point, but in a realistic, we don't have any electrical appliances having the power rate of only 1 watt. We don't have like that. In realistic, note this point, in a realistic, we don't have any electrical appliances having the power rating of 1 watt. 1 watt. All the appliances having more than 10 watts, 15 watt, 20 watt and so on. Okay, you might have heard that word. You might have heard that word, a 0 watts bulb. 0 watts bulb. Okay, it is used in night lamp. So that that bulb will be in different colors, the blue color, yellow color, green color, white color, and so many colors will be there. Actually, we are telling that is 0 watt bulb. Actually, that is not a 0 watt bulb. 0 watt bulb. If the watt, which means power, is 0, note this point. If the power is 0, then the energy consumed by object, which means electrical appliance, will be 0. So here the bulb will not glow. The bulb will not glow. Then how it is possible to 0 watt? There is no possibilities to get the power rating of 0 watt. But economically, we are saying that the sellers, the electricity bulb sellers, they are mentioning like that 0 watts bulb, 0 watts bulb, and 0 watts bulb, like that. Actually, no one electrical appliance is having 0 watt and 1 watt like that. Is that clear, students? Yes, very easy one. Okay, yes. So come to the content here. Here 1 watt is a very smallest unit. Already we know watt is a very smallest unit, but that electrical appliance is functioning in seconds. Here the time is given in seconds. So here 1 watt and 1 second is a very smallest unit. What is that? Very smallest unit. So this unit is not convenient for commercial unit of electrical energy. This unit is not convenient to measure the electrical energy in commercially. That is a reason why we need another one formula to calculate the electrical energy commercially. Is it clear? Yes, that is the reason why this energy formula is not convenient, students. That's all. Okay, because here the power rating is given in watt and time is given in seconds. For example, look at here. For example, the fan has 150 watt power. Then the microwave oven is example, is for an example, not exact meaning, it's approximate meaning, approximate value. Okay, the microwave oven having the 2000 watt. Then water heater, the water heater having 1000 watt. Then mixer grinder, that power rating is 750 to 1500 watt. 1500 watt. Yes. Next, the washing machine. What is that? Yes, that washing machine power rating is 3000 watt, students. 3000 watt. So we are having the electrical appliances power rating is bigger and bigger. Okay, bigger and bigger. That is in the rate of 1000 watt, 100 watt, 1000 watt, and 500 watt, 2000 watt, 3000 watt, and so on. But in this formula, this power rating is in smallest unit as in the form of watt, only 1 watt. So this is very smallest unit. That is the reason why we cannot use this formula to calculate the electrical energy commercially. We cannot calculate that. Okay, we cannot use this because it's very smallest unit. So 1 joule is note this point here. 1 joule is a very smallest unit. 1 joule is a very smallest unit. That is the reason why it is inconvenient to measure the electrical energy commercially. That is the reason why we need some alternative formula commercially to calculate the electrical energy. Is it clear? That's all, students. Okay. Is it clear? Yes, because the different electrical appliances having a power rate will be more and more. 1000 watt, 2000 watt, and so on. For example, in factories the machinery's power rating is more and more. That is very bigger unit. So all the time we cannot use this formula because watt is a very smallest unit and time second is a very smallest unit. So we cannot use this formula. So 1 joule is a very smallest unit. Is that clear? That's all. Shall I explain Tamil? Yes. Alla gavanichuko. நம்ம எனர்ஜியை கால்குலேட் பண்ணுறதுக்கு ஒரு ஃபார்முலா வேணும். அந்த ஃபார்முலா என்ன அப்படின்னா எனர்ஜி விச் இஸ் ஈக்குவல் டு பவர் இன்ட்டு டைம். எனர்ஜி தட் இஸ் ஈக்குவல் டு பவர் இன்ட்டு டைம். எஸ், ஓகே சார். ஸோ இது வந்து ஸ்மால் அமௌண்ட்னா ஓகே சார். ஃபார் எக்ஸாம்பிள் நம்ம வீட்டில் ஃபேக்ட்ரிஸ்லாம் பெரிய மிஷின்ஸ்லாம் ஒர்க் ஆகிட்டுருக்கு. அது என்ன 1 செகண்ட் 2 செகண்ட்லேயே ஒர்க் ஆகும். த்ரூ அவுட் தி டே ஃபுல்லாகவே ஒர்க் ஆகும். ஓகே, 20 hours 50 hours and more than 10 hours வரையாக ஒர்க் ஆகிட்டே இருக்கும். ஓகே, ஸோ அந்த மாதிரி ஒர்க் ஆகிட்டு இருக்கும்போது நம்ம எவ்வளோ எனர்ஜியை கன்சியூம் பண்ணியிருக்குது ஒவ்வொரு எலக்ட்ரிக்கல் அப்ளையன்ஸும் நம்ம கால்குலேட் பண்ணணும்னா நம்ம இந்த ஃபார்முலாவை எடுத்துக்க முடியாது. ஏன் அப்படின்னா நல்லா கவனிச்சுக்கோ, இங்கே எஸ்ஐ எனர்ஜியோட எஸ்ஐ யூனிட் வந்து ஜூலு, பவரோட எஸ்ஐ யூனிட் வாட்டு அண்ட் டைமோட எஸ்ஐ யூனிட் வந்து செகண்ட். ஓகே, ஸோ 1 போட்டுனா 1 ஜூல் தட் இஸ் ஈக்குவல் டு 1 வாட் இன்ட்டு 1 செகண்ட். அதாவது என்ன மீனிங் அப்படின்னா 1 வாட், நோட் திஸ் பாயிண்ட், 1 வாட் பவர் ரேட்டிங் உள்ள ஒரு எலக்ட்ரிக்கல் அப்ளையன்ஸஸ் 1 செகண்ட் ஃபங்க்ஷன் ஆச்சுன்னா அது எவ்வளோ எனர்ஜியை கன்சியூம் பண்ணும்? 1 ஜூல் எனர்ஜியை கன்சியூம் பண்ணும். 1 ஜூல் எனர்ஜியை கன்சியூம் பண்ணும். ஆமாவா? எஸ். ஆனால் ரியாலிஸ்டிக்காக 1 வாட்டுங்கிறது ரொம்ப 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 ஒரு லோவான ஒரு ஸ்மாலஸ்ட் யூனிட் ஆஃப் பவர். 1 யூனிட்டில் மேக்ஸிமம் எந்த ஒரு எலக்ட்ரிக்கல் அப்ளையன்ஸஸ் இருக்கிற மாதிரி இல்லை. ஓகேவா? ஸோ அது இல்லாமல் டைம் வந்து 1 செகண்டில் கொடுத்துருக்கான். ஏன்னா எலக்ட்ரிக்கல் அப்ளையன்ஸாக 1 செகண்ட் 2 செகண்டில் ஒர்க் ஆகிட்டு நம்ம வீட்டில் பார்த்தீங்கன்னா நம்ம டிவி பார்த்தோன்னா ஒரு 10 ஹவர்ஸ் மினிமம் 10 ஹவர்ஸ் பார்ப்போம். ஆமாம், அதே சம்மர் டைம்ஸ்னால் ஏசி ஓடிட்டே இருக்கும், ஃபேன் ஓடிட்டே இருக்கும், ஹார்ஸ் அதாவது 3 ஹவர்ஸ் 5 ஹவர்ஸ் அண்ட் மோர் தென் 10 ஹவர்ஸ் கூட ஓடிட்டே இருக்கும். ஸோ அப்படி இருக்கும்போது நம்ம செகண்ட்ஸில் நம்ம எடுத்துக்க முடியாது. ஓகேவா? ஸோ ஹியர் 1 ஜூல் இஸ் அ வெரி ஸ்மாலஸ்ட் யூனிட். 1 ஜூலுங்க அப்படிங்கிறது ரொம்ப ரொம்ப சின்ன யூனிட்டு. ஸோ இதை வந்து நம்ம என்ன பண்ண முடியாது, நம்ம கமர்ஷியலாக யூஸ் பண்ண முடியாது. அதுக்காக தான் நமக்கு என்ன வேணும், ஒரு ஆல்டர்னேட்டிவ் யூனிட் வேணும் கமர்ஷியலி டு கால்குலேட் தி எலக்ட்ரிக் எனர்ஜி. அந்த ஃபார்முலா தான் நம்ம பார்க்க போகிறோம். அவ்வளோதான் ஸ்டூடெண்ட்ஸ், வேறு எதுவுமே கிடையாது. ஓகே, பார்த்துக்கோங்க, எக்ஸாம்பிள் கொடுத்துருக்கேன். ஸோ இது எல்லாமே பவர் ரேட்டிங் எப்படி இருக்குன்னா பார்த்துக்கோ, 1000க்கு மேலே தான் இருக்குது, 1000 500 இந்த அதுக்கு மேலே தான் இருக்குது. ஸோ இங்கே 1 வாட்டுங்கிறது ரொம்ப ரொம்ப ஸ்மால் ஒன். ஸோ அதனால் நம்ம என்ன பண்ண போகிறோம், ஒரு ஆல்டர்னேட்டிவ் யூனிட் நமக்கு வேணும். அந்த ஆல்டர்னேட்டிவ் யூனிட் என்ன சார் நம்ம பார்க்க போகிறோம். ஓகேவா? தட்ஸ் ஆல், isn't it? Very easy one. Okay students, yes. Next one. Okay sir, 1 joule is a very smallest unit sir. Okay, 1 joule is a very smallest unit sir. Then what formula we can use to calculate the energy sir? What is the alternative formula sir? What is the alternative formula? That is very big question. That is very big question. Okay, so look at here. Okay, so now we have seen commercial unit of electrical energy. Am I right? Why sir? Why do we need commercial unit of electrical energy? Because 1 joule is a very very smallest unit, so we cannot use that formula to calculate the electrical energy. Actually that is inconvenient to calculate the electrical energy, because 1 joule that is equal to 1 watt into 1 second. But most of the electrical appliances having then power rating is more and more, that is like 1000 watt, 2000 watt, 3000 watt and so on. But and then the machines, electrical appliances functioning in hours, throughout the some machines are working throughout the day. So here the time is given in seconds, so that is inconvenient to measure that. Thus we need some alternative formula. Okay, yes. So second one, now we are going to see what is that alternative formula sir. What is that alternative formula? Okay students, yes, listen here. Already we know energy which is equal to what is that? What? Yes, power into time. Power into time. Okay, energy that is equal to power into time. Okay, already we know very well. Yes, look at here. Already we know 1000 watt which is equal to 1 kilowatt. 1000 watt which is equal to 1 kilowatt, isn't it? Yes. Now I am going to mention this power in kilowatt. In kilowatt, yes, I am going to take this one, because already we know watt is a very smallest unit and kilowatt is the biggest unit. I am going to take this biggest unit for my convenient. Okay, yes. So I am going to mention this power in terms of kilowatt. So power SI unit, what is it? Power SI unit is watt. Already we know power SI unit is watt, but watt is a smallest unit, so I am going to take kilowatt. So here I have mentioned kilowatt. So power is taken in terms of kilowatt. Is it clear? Yes. Into time. The SI unit of time is seconds, but second is a very smallest unit, so I am going to take the time in terms of hour. Okay, yes, in terms of hour. Isn't it? Yes. So look at here, put 1 here, also 1 and here also 1. Is it clear students? Yes. So here again, here also the SI unit of the SI unit of energy will be Joule. Energy will be Joule, isn't it? Yes, Joule. See, 1 Joule, note this point here in terms of power in kilowatt and time in hour, 1 Joule, that is equal to 1 kilowatt hour. 1 kilowatt hour, isn't it? What is that? 1 kilowatt hour. So look at here. So here 1 Joule, which is equal to 1 kilowatt hour. This is in terms of, note this point, this is in terms of kilowatt and hour. But previous, just before that, we have seen the Joule in terms of watt and seconds. But here we have seen the Joule in terms of kilowatt and hour. So look at here. So here energy that is equal to, note this point, here energy which is equal to, what is that? 1 kilowatt into 1 hour. 1 kilowatt into 1 hour. Sir, what is it meaning, sir? I can't understand, sir. What is it meaning, sir? You may ask me like that. I'll explain. You don't get panic. Okay, listen here. So what is that meaning, sir? What is that meaning, sir? Look at here. Here, note this point here. 1 kilowatt amount of, note this point, 1 kilowatt amount of electrical energy is consumed when an electrical appliance is having the power rate of 1 kilowatt and it is used for 1 hour. That's all. That's all, very easy one. Okay, so what is it, sir? You repeat again, sir. You may ask me. Listen here. 1 kilowatt amount of electrical energy is consumed when an electrical appliance is having the power rating of 1 kilowatt and it is used for 1 hour. That's all. That's all, sir. Very easy, sir. Very easy. Sir, I can't understand, sir. You are thinking like that. Am I right? Sir, this is not understandable, sir. You explain with the example, sir. Am I right? Yes. I can hear like that. Okay. I'll explain with an example. I'll explain with an example. Okay. So look at here. Consider an electric circuit. Here, for example, I have taken electric bulb. That is an electric bulb, plus minus. So we applied 220 volt potential difference. We applied 220 volts potential difference across the two terminals of the battery, isn't it? Yes. So due to this potential difference, current gets flowing throughout the circuit. Is it clear, students? Yes. So here in this electric circuit we have calculated the electric bulb. Okay. Do you want electric bulb or any other device? Because electric bulb power rating will be very, very small. So we can take another one. No problem. We can take another one, isn't it? So what we can take, sir? We can take a washing machine. Yes. Washing machine here. Yes. Washing machine is here. Washing machine is here. In this electric circuit, we have connected a washing machine across the two terminals of the battery. Is it clear? Yes. We apply 220 volt. So due to the potential difference, current gets flowing throughout the circuit. Isn't it? Yes. So washing machine is one of the electrical appliance. Isn't it? Yes. Note this point. Here, this washing machine power rating is, just consider 1 kilowatt, which means 1000 watt, or otherwise we can say 1 kilowatt, because 1000 watt which is equal to 1 kilowatt already we know very well, isn't it? Yes. Note this point. Here, this washing machine power rating is 1000 watt, which means 1 kilowatt. 1 kilowatt, isn't it? So we apply the potential difference, due to which that washing machine is functioning. That washing machine is running. Suppose if the washing machine is used for, which means functioning for 1 hour, time how much? Time 1 hour. 1 hour. Look at here, 1 hour. Here the washing machine will consume 1 kilowatt hour amount of energy. 1 kilowatt hour amount of energy. 1 kilowatt hour amount of energy. That's all, student. Sir, okay, sir. So if if the washing machine having the power rate of 1 kilowatt and is used for 1 hour, it will consume 1 kilowatt hour amount of electrical energy, sir. So 1 kilowatt hour which is equal to how much amount of energy, sir? That is very big question. Am I right? 1 kilowatt hour, that is equal to how much amount of electrical energy? Then how that is equal to how much amount of joules? That's all. That is question. Okay, students. So that is called. So what is 1 kilowatt hour? What is 1 kilowatt hour? So 1 kilowatt hour amount of electrical energy is consumed when an electrical appliance is having the power rating of 1 kilowatt and it is used for 1 hour. 1 hour. Is it clear? If the electrical appliance is having the power rate of 1 kilowatt hour and it is used for 1 hour, then it will consume 1 kilowatt hour amount of electrical energy. 1 kilowatt hour amount of electrical energy. Is that clear, students? Very easy, students. Very, very easy. So here 1 kilowatt hour, that is commercial unit of electrical energy. 1 kilowatt, note this point here, the 1 kilowatt hour, that is commercial unit of electrical energy. This is very important, one more question. So the commercial unit of electrical energy is kilowatt hour. Kilowatt hour. Okay, so here the watt, that should be in capital letter. Kilowatt hour. That's all. Very important. One more question. So commercial unit of electric energy, what is that? Kilowatt hour. Kilowatt hour. Have you seen the domestic electricity meter? The domestic electricity meter is fitted in everyone's house. Okay, at your house there will be domestic electricity meter. In my house there will be domestic electricity meter. Okay, have you ever seen domestic electricity meter? Okay, so if you have time, you go and see the domestic electricity meter. There will be this commercial unit of electrical energy, which means there will be kilowatt hour unit. There will be kilowatt hour unit, because electrical energy commercially calculated by, which means measured by the unit, that is kilowatt hour. That is kilowatt hour. Very easy one. Very, very easy one. That's all, students. Very easy one. Okay, so this is called commercial. This is commercial unit of electrical energy. So kilowatt hour, that is commercial unit of electrical energy. Okay, see, look at here, 1 joule. So 1 joule is a very, very smallest unit. 1 joule, that is equal to 1 watt into 1 second. That is very, very smallest unit. So commercially, to calculate the electrical energy, we need some alternative formula. That alternative formula is a kilowatt hour. Kilowatt hour. Look at here. So already we know energy, which is equal to power into time. I have taken this power in terms of kilowatt. Because already we know watt is the very smallest unit. So I have taken kilowatt, and time I have taken in terms of hour, because SI unit of time is second. That is too small. That is the reason I have taken in hour, isn't it? So energy, which is equal to kilowatt hour. Energy which is equal to kilowatt hour. Okay, which means what is that, sir? So already we know SI unit of energy is 1 joule. SI unit of energy is joule, sir. So 1 joule, that is equal to 1 kilowatt hour. So 1 kilowatt hour, which is equal to how many joules of energy, sir? That is very big question. That we will see later. Is it clear? So commercial unit of, know this point. So commercial unit of the electrical energy is kilowatt hour. So what is 1 kilowatt hour, sir? What is 1 kilowatt hour? Look at here. So 1 kilowatt hour amount of energy is used when an electrical appliance is having the power rating of 1000 watt, which means 1 kilowatt, and it is used for 1 hour. That is called. That's all. Okay, which means when an electrical appliance is having the power rating of 1000 watt, which means 1 kilowatt, and it is used for 1 hour, then it will consume, note this point, then it will consume 1 kilowatt hour amount of energy. 1 kilowatt hour amount of energy. That's all, students. So next question is here, sir, 1 kilowatt, which is equal to how much amount of electrical energy, sir? That is very big question. I mean, that is good question. So 1 kilowatt hour is equal to how much amount of electrical energy, sir? Next we will see that. Next we will see. Okay, students, yes, listen here. I'll rub this side. Okay. So on that also I'll rub this. So the relationship between kilowatt hour, what is this? Kilowatt hour and joules. The relationship between the kilowatt hour and joule. There is some relationship between the kilowatt hour and the joule. So what is that relationship, sir? What is that relationship? Look at here. So 1 kilowatt hour, 1 kilowatt hour which is equal to 1 kilowatt hour which is equal to what will be there? Yes, 1 kilowatt amount of electrical appliances used for 1 hour. Am I right? Yes, 1 kilowatt for 1 hour. Am I right or wrong? Yes. So 1 kilowatt, that is 1 kilowatt hour which is equal to 1 kilowatt for 1 hour, which means 1 kilowatt hour which is equal to 1 kilowatt amount of power rating, 1 kilowatt having the power rate of electrical appliances running for 1 hour, which means functioning for 1 hour, isn't it? So we can write 1 kilowatt hour which is equal to 1 kilowatt for 1 hour. Is it clear, students? Yes. Look at here. Then 1 kilowatt hour which is equal to, so already we know 1 kilowatt that is equal to 1000 watt. So already we know, look at here, already we know very well, 1000 watt which is equal to 1 kilowatt. 1000 watt is equal to 1 kilowatt. So I am going to take this 1000 watt instead of this 1 kilowatt. Okay, yes. So 1000 watt for 1 hour. Yes, for 1 hour. Okay, because look at here, because 1000 watt that is equal to 1 kilowatt, isn't it? Yes, look at here. I'll rub this because no need. Listen here. We can write this 1000 watt in terms of 1 watt into 1000. Am I right or wrong? Obviously we can write. Look at here. We can write this 1000 watt into in other manner 1 watt into 1000. If you add, we can get the same value. I mean, if you add these two, we can get same value. So we can write this term into like this. So both are same. Both are same. You don't get confusion. Okay. So look at here. I have written this 1000 watt into like this manner. 1 watt into 1000. 1 watt into 1000. To get the energy value, we need to write like that. Okay. You don't get confusion. Yes. So we have written 1 watt into 1000. So for here the time value has given in hour. If you convert this hour into seconds, so 1 hour which is equal to how many seconds? 3600 seconds. Am I right? You write here 3600 seconds. 3600 seconds. Is that clear, students? Very easy, students. Don't get confusion. Okay. Yes. So here write 1 kilowatt hour. 1 kilowatt hour. Is that clear? Yes. See, look at here. Here 1 watt is here. 1 watt is here. What is 1 watt? So already we know 1 watt which is equal to 1 joule. I'll write there because I need some space. Sorry, no problem. You write 1 joule divided by 1 seconds. 1 joule divided by 1 second. Look at here. Already we know very well 1 watt that is equal to 1 joule divided by 1 second. Okay, yes. So substitute this value here instead of this 1 watt. Instead of this 1 watt. Okay, yes. I'm going to substitute this 1 watt value instead of this 1 watt. Okay. So 1 kilowatt hour which is equal to, you substitute this value, 1 joule divided by 1 second into 100 sorry 1000, not 100, 1000. Okay, remain, I'll write there. Look at here. Into 100 into 3600 seconds. See, 3600 seconds. Okay, just I have modified that. That's all. So look at here. Here from this formula, seconds cancel. Am I right? Seconds cancel, and remaining what will be there? What will be there? Look at here. 1 joule and 1000 and 3600. That's all. You multiple both. 1000 into, note this point. 1000 into 3000. Sorry, 1000 into 3600. What will be there? So there will be. Look at here. So 1 kilowatt hour. I have modified this. Okay, in terms of symbols. 1 kilowatt hour, which is equal to, you multiple all. So that is equal to, what is that? 1000. Just multiple, because I don't have space here. So what will be there? 1000 into 3600. What will be there? So 36 into, after that how many zeros will be there? 1 2 3 4 5. 5 zeros will be there. 1 2 3 4 5. And joule, remaining joule is there. Second cancel. So joule. That's all, students. Look at here. So 1 kilowatt hour, which is equal to how much? How much? That is equal to 36 lakhs joule. 36 lakhs joule. Okay, yes. So another one way we can write the same formula, we can write in another way. I'll write there because I don't have space. Look at here. I don't have space. Look at here. So 1 kilowatt hour, which is equal to, we can write 3.6 into 10th power of 6 joule. That's all, very easy one. So can you get some idea now? So 1 kilowatt hour, that is equal to 3.6 into 10th power of 6 joules. Okay, yes. So 1 kilowatt hour, which is equal to 3.6 into 10th power of 6 joule amount of energy. So look at here, 1 kilowatt, that is equal to 3.6 into 10th power of 6 joule amount of energy. Is it clear? So what is that meaning, sir? What is that meaning, sir? The 3.6 into 10th power of 6 joule. What is that meaning, sir? Look at here, already we know. Here the washing machine power rating is 1 kilowatt. The washing machine power rating is 1 kilowatt, which means 1000 watt, isn't it? Yes. So if the washing machine is used, which means functioning for 1 hour, it will consume how much amount of energy? 3.6 into 10th power of 6 joule amount of energy. That is equal to 1 kilowatt hour. That is equal to 1 kilowatt hour. So whenever an electrical appliance is having the power rate of 1 kilowatt and is used for 1 hour, then it will consume 1 kilowatt hour amount of energy. That 1 kilowatt hour amount of energy, which is equal to 3.6 into 10th power of 6 joule amount of electrical energy. That's all, students. 3.6 into 10th power of 6 plus 6, not minus 6, plus 6 amount of electrical energy, which means joule. That's all. That is the meaning. That is the meaning. That's all. So kilowatt hour is the commercial unit of electrical energy. Note this point. There is some relationship between the kilowatt hour and the joule. That is, look at here. So 1 kilowatt hour is equal to 1 kilowatt for 1 hour, which means 1 kilowatt hour is equal to the electrical appliance is having the power rate of 1 kilowatt, and it is used for 1 hour. And it is used for 1 hour, isn't it? So again we can write 1 kilowatt hour, which is equal to, here 1 kilowatt that is equal to 1000 watt. Already we know very well. So mention that 1000 watt for 1 hour. 1 hour, isn't it? Yes. So again 1 kilowatt, left hand side equal 1 kilowatt hour, which is equal to, we can write, know this point, we can write this 1000 watt in terms of 1 watt into 1000. Both are same here. Both are same. You don't get confusion. If you multiple both, there will be 1000 watt. That's a 1000 watt. So for get the formula, I have modified like that, isn't it? Yes. So we can write 1 watt into 1000. For here the time is given in hour. So convert this 1 hour into seconds. We can get 3600 seconds. 3600 seconds, isn't it? So already we know 1 watt which is equal to 1 joule divided by 1 second. Already we know very well. Okay, 1 watt that is equal to 1 joule divided by 1 second. So substitute this 1 watt value in this formula. So left hand side equal, that will be 1 kilowatt hour, which is equal to, instead of this 1 watt, you mention 1 joule divided by 1 second into that 1000 is here, remains same here, into 3600 seconds. So here seconds cancel, and remaining all terms you just multiple. So 1000 into 3600, which is equal to 36 lakhs. Am I 36 lakhs? And joule is there. So here 1 kilowatt hour, which is equal to, what is that? 36 lakhs joule. Okay, so this is a very small, bigger one. So we have simplified like this: 3.6 into 10 to the power of 6 joule. So 1 kilowatt hour, which is equal to 3.6 into 10 to the power of 6 joule, isn't it? So what is it meaning, sir? So whenever the electrical appliances having the power rating of 1 kilowatt, and it is used for 1 hour, it will consume 3.6 into 10 to the power of 6 joule amount of electrical energy. Suppose, look at here, suppose consider the washing machine. That washing machine power rate is 1 kilowatt. If the washing machine is used for 1 hour, it will consume 1 kilowatt hour amount of energy. 1 kilowatt hour amount of energy. Here the 1 kilowatt hour, which is equal to 3.6 into 10 to the power of 6 joule. That's all. So if the washing machine having the power rating of 1 kilowatt hour and it is used for 1 hour, it will consume 3.6 into 10 to the power of 6 joule amount of electrical energy. That's all. Electrical energy. Is it clear? A very simple concept. Very simple concept. Okay, students, that's all. So 1 kilowatt hour, that is a commercial unit of electrical energy. 1 kilowatt, that is equal to 3.6 into 10 to the power of 6 joules. Khatam. Okay, yes. Keep this all concept in your mind. Okay, yes. That's all, students. So this concept completed. Next, see, we are going to make 1 or 2 sums basis on this one. Basis on this commercial unit of electrical energy. I'll rub this. So look at here. Basis on this electric energy consumed topic, if the power rating is given in watt, you must convert this watt into kilowatt. You must convert this watt into kilowatt, because commercial unit of electric energy is kilowatt, isn't it? Suppose if the time is given in seconds or minute, you must convert this seconds and minutes into hour, because commercial unit of electrical energy time unit is hour. Okay, students? Yes, that's a very easy one. We will see 1 or 2 numericals. Okay, yes. Let's get started. First numerical. Calculate the energy transferred. Calculate the energy transferred by a 5 ampere current flowing through a resistor of 2 ohm, mention in symbol, 2 ohm for 30 minutes. 30 minutes. Okay, listen here. The question is, look at here. The question is, calculate the energy transferred by a current value. How much? Current, 5 ampere current flowing through a resistor 2 ohm for 20 minutes. Okay, we need to calculate what? We need to calculate energy. Okay, so let's get started with solution. So what is the formula to find out the energy? Yes, energy which is equal to power into time. Already we know very well. Power into time, which means E which is equal to P into T. Already we know very well. We know very well. First you write what are the values we know. Look at here. Here the current value is I which is equal to 2 ampere. Sorry, 5 ampere. Not 2 ampere. 5 ampere. Then the resistor R which is equal to 2 ampere. Then T which is equal to 30 minutes. Then what we need to calculate? Energy we need to calculate. Energy we need to calculate. Look at here. To calculate the energy, what are the quantities we need? Energy that is equal to power into T, which means time. Energy that is equal to power into time. We have time, but what is power, sir? Where is power? First you find out the power. First you find out the power. Is it clear? Yes. So listen here. So remain right here. So power which is equal to what formula? To calculate power we have three formulas. First formula, that is P equal to V into I in terms of voltage and current, and second formula P that is equal to I square R in terms of current and resistance, and third formula that is P that is equal to V squared by R, that is in terms of voltage and resistance. Here what formula we need to take? Look at here. Here we have I value and R value. We know I value and R value. Here which formula we can do? Which formula we can choose? I, R. Second formula we can choose. First formula we cannot choose this. There is no R. There is no R in second formula. Sorry, in first formula. And what about the third formula, sir? In third formula there is no I. So which formula we can choose? We can choose second formula, I square and R. That's all, students. This is how we need to make. Very simple. This is how we need to make. Okay, so we can choose power IP that is equal to I square R. I square R. Okay, yes, I'll write here. We can choose P that is equal to I square R. Okay, yes, what is I value, sir? I value 5. So 5 square into R value how much, sir? R value 2. So what will be the value? What will be the value? Yes, 5 square 25 into 2. So power which is equal to 50 watt. Power which is equal to 50 watt. Is it clear? Yes. So already we know in the concept of electrical energy, power should be in only kilowatt. Only kilowatt, because the commercial unit of electrical energy kilowatt hour. So power should be in kilowatt and time should be in hour, isn't it? Yes. So look at it here. The time is in, what is that? In minutes. 30 minutes. So 30 minutes which is equal to 1/2 hour. Am I right or wrong? Yes. 30 minutes equal to 1/2 hour, or otherwise we can take 0.5 hour. Both are same here. For my convenient I have taken like that. Okay, it's 1.2 hour. Okay, yes. And here the power is in watt. Convert this watt into kilowatt. So here power value will be 0.05 kilowatt. 0.05 kilowatt. So how it is possible, sir? How it is possible, sir? Look at here. Already we know 1000 watt that is equal to 1 kilowatt. 1000 watt that is equal to 1 kilowatt. So 1 watt which is equal to 1/1000 kilowatt. 1/1000 kilowatt. So 50 watt which is equal to 50 divided by 1000 kilowatt. So 0 cancel. So 5/100 which is equal to 0.05. Am I right? Yes. So that is equal to 0.05 kilowatt. Am I right? Yes. Okay, students. Yes, that's all. So now calculate the power. Remind, I'll write there. Now calculate the power. Sorry, energy. So E that is equal to P into T. The P value is 0.05 kilowatt, and time how much? 1/2 hour. 1/2 hour. Is it clear? It's a very easy one, so you don't get confusion. Okay, yes. Here what will be the value? What will be the value here? Here you again you divide that. That will be equal to what will be there? Yes, 2.5. So here the value will be 0.025 kilowatt hour. Okay, because 0.05 divided by 2 which is equal to if you further divide, that will be 25. So which is equal to 0.025 kilowatt hour. So energy that is equal to, what is that? 0.025 kilowatt hour. That's all. That's all. This is how we need to make students. Okay, so this is one type of numericals. Okay students, that's all. So here power in kilowatt and the time in hour. So total energy that is equal to 0.025 kilowatt hour. That's all. So this is one type of a numerical. Remaining, I'll make another one. Okay, yes. Let's listen here. Another one numerical. So this is the last numericals. Okay, yes. Listen here, the second numerical as well as the last numerical. An electric heater draws current of 10 ampere from a 220 watt supply, volt supply, volt supply. What is the cost? What is the cost using the heater for 5 hours, for 5 hours every day for 30 days, if the cost of 1 unit, note this point, very important point, the cost of 1 unit is 1 unit, which means 1 kilowatt hour. Note this point, very important point, 1 unit, which means 1 kilowatt hour. So 1 kilowatt hour is which is 5.20 rupees. Okay, how much? 5.20 rupees. Now calculate that. Okay, listen here. What is the question? An electric heater draws a current value 10 ampere from the voltage 220. What is the cost using the heater for 5 hours? 5 hours every day. Now this point I'll write there, every day for 30 days. Okay, that is equal to 1 month. Yes. If the cost of the 1 unit electricity charge, note this point, if the cost of the 1 unit electricity charge is 5.20 rupees. 5.20 rupees. Okay, which means 5 rupees 20 paisa. 20 paisa. Yes. Here what we need to calculate? Here, how much amount of electrical energy which is consumed by the electric heater when it is running for 5 hours every day for 30 days. That is the question. Okay, 1 unit electricity charge is 5.20 rupees, which means 5 rupees 20 paisa. 20 paisa. Okay, yes. So if the electric heater runs every day 5 hours for every day, in 30 days how much amount of electric energy it will consume? That is a question. Okay, so let's get started with solution. First you write what are the values you know. I value we know, that is 10 ampere. Then what is that? Voltage 220 volt, and this heater time is given here. Time is what is that? 5 hours for 30 days. 5 hours for 30 days, isn't it? Yes. Now what we need to calculate? Energy we need to calculate. Am I right? Energy we need to calculate. Yes. Look at here. So already we know energy formula. Energy which is equal to power into time. Power into time. Time is here. 5 hours for 30 days. Time we have that. Then what is the power, sir? Where is the power? Do you know what is the power value? No. We need to calculate power. So here power which is equal to, what is the value? To calculate the power we have three formulas. First formula, what is that? P, that is equal to V into I. Second formula, what is that? I squared R. And third formula, what is that? V squared by R. Here what are the values we know? Note this point. Here V, I value we know, current value we know, V value we know, voltage value we know. Here which formula we can choose? V into I. First formula we can choose. First formula we can choose. Yes. So we can choose the power formula P, that is equal to V into I. So what will be the value? V value how much? V, yes, 220 volt into current value 10 ampere. So power value will be, what is that? 2200 watt. 2200 watt. That's all, students. That's all. Very simple. Very simple. Then convert this watt into kilowatt. So here 2200 watt, which is equal to how many kilowatt? 2.2 kilowatt. Am I right? So which is equal to 2.2 kilowatt. So I'll write here power which is equal to 2.2 kilowatt, because here the power value is 2200 watt. If you convert this watt into kilowatt, that will be 2.2 kilowatt. Very simple. Very, very simple. Yes. Next, look at here. Here, the time, how can we calculate the time, sir? How can we calculate the time? Because look at here. Here the electric heater is functioning every day 5 hours. Okay, every day 5 hours. So if it is works 5 hours for every day, how much hours it will run for 30 days? 30 days. Look at here, time. Okay, look at here. Here. Per day the electric heater functioning, which means running 5 hours. What is that? 5 hours. So 30 days electric heater functioning equal to, what will be there? Yes, 5 into 30. 5 hour into 30. So what will be the value? Okay, what will be the value? See, if the electric heater functioning 5 hours per day and 30 days, how many hours it will function? So 5 into 30, that's all. So which is equal to 150 hours. Which is equal to 150 hours. So time is equal to 150 hours. What is the time? Is equal to 150 hours. That's all. Then simplify. Substitute these all values. So energy which is equal to P into T. The P value how much? Energy value 2.2 kilowatt. So 2.2 kilowatt into time value, yes, 150 hours. 150 hours. Okay, yes, so you further divide. So 150 into 22, what will value? 0, 10, 0, remaining 1, 2, 3, again 0, 0, sorry, again 0, 10, 0, remaining 1 and 2 and 3. So remaining 3, 3, 0, 0. Okay, which means, okay, after one digit dot is there, so here put dot. So the value will be, look at here, energy will be 330 kilowatt hour. That's all, students. 330 kilowatt hour. If, look at here, if the electric heater having the power rate of, notice the point, having the power rate of 2.2 kilowatt hour, or used for, note this point, used for 150 hour, it will consume, note this point, it will consume 330 kilowatt hour amount of energy. That's all. Look at here. If the electric heater function, note this point, if the electric heater having the power rate of 2.2 kilowatt and it is used for 150 hours, it will consume 330 kilowatt hour electrical energy, isn't it? Yes. Look at here. Here the question is, if the cost of 1 unit is 5 rupees 20 paisa, how much amount of cost will be there? Okay, after consuming of 330 kilowatt hour, that is question. Note this point here. 1 kilowatt hour, that is equal to 1 unit. 1 kilowatt hour, that is equal to 1 unit. So note this point. So here kilowatt hour how much? 300. Here the kilowatt, which means the energy value how much? 330 kilowatt hour, isn't it? Yes. Then what will be the value, sir? What will be the value? So look at here, 1 unit cost is 5.20 rupees. So 5.20 rupees into how much? Here the unit is how much? 330 kilowatt hour. So multiple that kilowatt hour. What is that? 5.20 into 330 kilowatt hour. So what will be the value, sir? What will be the value, sir? So there is no need to mention here, because we need to calculate only the cost, so there is no need. You further multiple that, so what will be that? So 520 into 330, what will be the value? 0, 0, 0, and remaining 0, 6 and 15, 1, 5, and again here 0, here 6, again 150. So what will be the 0, 0, 6, 11, 1, here 1, and 6 and 1. 7, 1. Okay, 0, 0, 6, here 11, so 1, here remaining 1, 5, 6, 7, and 1. So which is equal to how much? After 2 dot is here, so put dot here, so this is equal to 1716 rupees. 1716 rupees. What is it? 1716 rupees. That's all, students. Here the cost is how much? Here the cost at the end of 30 days, it is used every day for 5 hours. The cost is 1760 rupees. That's all. Okay, on the basis of 1 unit charge is 520 paisa, students. Very easy, students. That's all. This is how you need to make numericals. Okay, students. Yes. So this class getting over. I hope this class will be very, very useful for you, because in this session we have discussed so many things. How to calculate the energy value, power value, then 1 unit, how to calculate the electricity bill, like that, so many things, isn't it? Yes. Thank you, students. Remaining only one topic is that the heating effect electric current. That topic we will see next class. Okay. Yes. Thank you.